Hi everyone, welcome back to my channel. In this video, I am going to solve Surface Chemistry CSIR NET previous year questions from 2016 and also 2011 to 2012. Video link I have mentioned in description. Please go through that. Now, let's move to the question. Question 1. This question I have found in CSIR NET model question paper. Let's go to the question. For a diffusion controlled bimolecular reaction, the rate constant Kd is proportional to T is equal to temperature and eta is equal to coefficient of viscosity of the medium. Here four options are given. Option A, eta into T. Option B, 1 divided by eta T. And option C, T divided by root of eta. And option D, T divided by eta. Now let's see the solution. For a diffusion controlled reaction, the rate constant is given by the Smolowski equation. The reaction rate depends on how fast molecules diffuse through the medium. So the diffusion coefficient D follows the Stokes-Einstein equation. Now D is directly proportional to T by eta since Kd directly proportional to D. Therefore, Kd directly proportional to T divided by eta. So the correct option is option D. Option D, T by eta. Now we'll see the trick. Diffusion increases with temperature and diffusion decreases with viscosity. So always remember Kd directly proportional to T by eta. Now let's move to the second question. Second question, this has asked in CSIR NET June 2016. The question is, when the river water containing colloidal clay flows into the sea, the major cause of settling is option A, accumulation of sand at the bottom, and option B, flocculation and coagulation, and option C, decreased salinity of seawater, and option D, visualization. Now, let's see the solution. Here the concept is when river water containing colloidal clay mixes with seawater, settling occurs mainly due to coagulation of colloids by electrolytes. So seawater contains a high concentration of salts, that is Na plus Cl minus Mg2 plus Ca2 plus etc., which acts as electrolytes. So we'll see the explanation. For clay particle for clay particles in river water are negatively charged colloids. They remain stable because of electrostatic repulsion. When they enter seawater, the electrolytes neutralize the surface charge. Then the electrical double layer gets compressed and also particle aggregates means flocculate. The aggregates becomes heavier and settle. This follows Hardy-Schulze rule. So, here's the summary is when river water containing colloidal clay meets seawater has a high electrolyte concentration and electrolytes neutralize the charge on colloidal particles. This causes aggregation, that means flocculation or coagulation. The particle settles. So, the correct answer is option B, flocculation and coagulation. Now, we'll see the why other options are wrong. In option A, they have given accumulation of sand at the bottom because here sand is not a colloid. Settling of clay colloid is due to coagulation, not sand deposition. And another one is option C, decreased salinity of seawater. Here the opposite is true. Seawater has high salinity which promotes coagulation. And in D, visualization. Visualization occurs in surfactant solutions. It is unrelated to clay colloids. So option B, coagulation and flocculation is the correct answer. Now let's move to the third question. This was asked in CSIR NET June 2016. The adsorption isotherms of three gases A, B and C are shown in the following figure, where theta is the percentage of surface coverage Here graph has given and three lines given A, B, C. The graph is 1 by theta versus 1 by P. Now let's see the solution. Here the correct order of the extent of adsorption of these gases is, here four options are given. Option A is A greater than B greater than C, and option B is B greater than A greater than C, and option C is C greater than A greater than B, and option D is C greater than B greater than A. Now we'll see the solution. Yet the concept used is Langmuir adsorption isotherm, and the key relation is the graph is plotted between y-axis 1 by theta and x-axis is 1 by p. So from the Langmuir adsorption isotherm, theta is equal to kp divided by 1 plus kp, rearranging 1 by theta is equal to 1 plus 1 by kp. This is of the form y is equal to mx plus c, where slope is equal to 1 by k and intercept is equal to 1. Now we'll see the interpretation. Higher adsorption tends to larger k and that tends to smaller slope, and lower adsorption tends to smaller k that leads to larger slope. Now from the graph, A is highest slope, so lowest adsorption, and B is medium slope, that means medium adsorption, and C is the lowest slope, that means highest adsorption. Therefore C greater than B greater than A. So the correct answer is option 4, C greater than B greater than A. I hope you understood this video. Now we'll see the quick trick. Suppose let's remember this, slope is equal to 1 by k. Smaller slope is equal to larger k, that is equal to greater adsorption, and larger slope is equal to smaller k, that is equal to lower adsorption. Final order of adsorption C greater than B greater than A. So I hope you understood this concept. In next video I will solve some more previous year questions. If you like this video, please like, share and subscribe to my channel. Thank you. Have a nice day.